So till now we have been looking at what the different data formats are. We talked about CSV, we talked about the fact that the data can be relational, non-relational, how much of it is in the database, etc. We also talked about how software is typically what produces all this data in the first place. So what is actually going on inside a typical software? And let's take a look at it from the perspective of how the data gets generated inside the software and how it's stored. Now, almost all software applications are backed by a database of some sort, right? Typically by a relational database, RDBMS, sometimes by NoSQL databases as well. But let's just think about it as a database. RDBMS is easy enough to understand, so let's just think about it that way. What are the types of data in a database? So these are basically data elements which are created by the software to support its workings. So in that regard, there are two types of data elements. Right? One is what's called as facts, or sometimes called as events. The other is called as dimensions, or sometimes called as masters. Now, facts are what constitute the core functioning of that particular software. So they describe a real-world event or a business process, and the software is actually meant for a particular business process. So therefore, facts are core to what the software produces as data exhaust. So the example here would be, if I am the ticket booking software as IRCTC, then the ticket booking itself is a fact, right? So that will be one example. The other example is the payment information, the confirmation of the payment. Who made the payment using what kind of an instrument, whether it's UPI or a card or things like that, and for what amount and for what ticket was this. That is also a fact, right? Now, you can think of it as an event, right? An event is the ticket was booked, that's an event, right? The payment was made, which is an event. And as a result, those events are meaningful in the world of ticket booking, in the world of IRCTC. So, that's on the fact side. The dimensions, on the other hand, lend flavor to the fact, right? So they're also called masters because they control how the facts get interpreted. So the example with the same IRCTC ticket booking app, you could think about the dimensions here referring to the person, right? The person has a mobile number, has whatever, right? Has an email address, has a name, has a family they're associated with. All of those are dimensions. But the fact that the ticket booking was made by that mobile number is the fact. So that's how the two distinguish from each other. Let's take a proper example. I've tried to denote the fact that this blue rectangle, or a blue table, sorry, and then the dimensions. There are two dimensions actually. Both of those are in orange color. So let's take a look at the fact itself. So we've seen train number 12456. Actual time of departure from Bikaner Junction is 4:45 p.m. So that's a fact, that's an event, right? That's already happened. A machine that takes a look at this data does not know what T-no refers to, what ATD refers to, what from refers to, what BKN refers to, right? All of those are just bytes. But a human looking at it can kind of understand where the context is train ticket bookings, and here it's about a train that's leaving a particular station. Now, what is BKN? Maybe some of you know, some of you don't know. You can then use the dimension which lends flavor, which talks about what BKN is, right? So I've got the set of all stations that's available as a master or a master table or a dimension table, and here station code is going to be in the exact same field format as the from column that's there in this fact table. And so from there I know BKN refers to Bikaner Junction, it's part of the Bikaner district of Rajasthan, right? Likewise, what does train 12456 refer to? That's actually the column that's present as T number, or T-no rather, in this dimension. And that dimension has additional items that add flavor to it, right? The train name is Bikaner Delhi Sarai Superfast Express, available classes of 1A, 2A, 3A, SL. So now, if I take all of those tables together, then I know I can actually make sense of the data that's actually been generated as facts. Notice that the volume of data that the IRCTC deals with is not the set of trains or the set of stations, right? That's finite in number, it's very small. Compared to the set of ticket bookings or the set of train arrivals and departures or the set of payments, those are voluminous because those occur on a day in, day out basis for the same dimension, for the same dimensional entry, right? Which means the same train 1, 2, 4, 5, 6 departs from the same station Bikaner multiple times during a year. For each of those departures I have an event. Accumulated over many years, this becomes very voluminous, right? But the number of trains itself is not voluminous. So keep that in mind. It's the facts that make volume, that's the facts that make it big data. So how does the software then change the data? How does it record the facts? How does it record dimensions and masters? So here's where you need to understand what are the options available for a typical software designer. For facts, which are basically events that are getting recorded, you could simply just do an append into a table, append into a file, doesn't matter, right? Let's remain in the world of databases, append into a table. An append into a table looks like insert into table values. So the example that we saw of train departed from a particular station is just an entry into a table which is recording all the train departures. I don't need to look at any other data in order to record that fact. That's why it's called an append. For dimensions, on the other hand, every time I need to do something about these dimensions, I have to do one of these 4 types of operations: create, read, update, or delete. Or in short, it's abbreviated as CRUD, C-R-U-D. So let's take an example. I have the set of all stations. Okay, let's take a train example, that's even better. I have the set of all train numbers. Every train number has a train name as an available set of classes. Now, the first time a new train is introduced, like for instance the Vande Bharat Express from Bangalore to Chennai, at that time, the software for IRCTC will need to go create a new entry, right, in this particular train catalog, which is recording that specific new train number. And there they will say Vande Bharat Bangalore to Chennai Express, available classes, etc., etc. So in that setup, what you've done is you've created a new entry. Now, let's say for instance this Bikaner Delhi Superfast Express 12456 has a new rake, and the new rake is actually a first class FC. So now I can come back and change the entry corresponding to 12456 in my table to include the class FC. To do that, what I would do first is read the current entry, see whether FC is there. If it's not there, update it. So in that setup, what I've done is I've done a read, I've then done an update. And of course, like I can imagine, I could also be doing a delete because I've sunset some train because the train is no longer popular, etc. So CRUD refers to standard ways in which the software needs to change dimensions, right? Either add or delete or update. So almost any database, in fact all databases, if I may say so, support CRUD, right? That's what makes it very amenable for software to use the database as a backend. So here's an example of the CRUD operation listing for one of the popular databases called Oracle. So here you can think about a create operation that's creating a new data object and its descendants meaning specific variations of that data object. Deleting is of course deleting the object. The get operation is getting a single object using some kind of a primary key. The primary key refers to that column which uniquely identifies a specific row of data. So for instance, I could do a primary key in this specific stations table as the station code column, so that even though the stations table might have like 100,000 or 1 lakh stations as an example, if I know I'm looking for BKN as the specific station of interest, I could do a query on top of this table and say station code equals BKN. Then that query becomes a get query because I'm looking for one specific value based on the primary key. The find, on the other hand, is searching for a bunch of different rows, all of which meet a certain criteria. So, as an example, I could do a find on the stations table for all the stations that belong to the state of Rajasthan, in which case I could get, like, let's say 1000 stations, right? So that's a find operation. And then you could have additional search criteria, etc. etc. Updating is just updating a business object. We spoke about that, data entry. Merge is basically saying either you update something which, if it already exists, but if it already doesn't exist, then create it new. So, as an example, when the Vande Bharat train is launched for the first time, and I have to make an entry, I might already have made an entry because I might be pre-populating it through some other mechanism. In which case, I just have to go and update saying, look, it's launched, it's ready, it's live. Or, if it doesn't exist, then create that Vande Bharat entry in the list of trains. And then, most generally, the process operation is just saying, I can do one of the different types of processes that are already supported. I'm not going to say what is the current process. I'm just going to let you figure it out by, defining the defining the process, right? So that's a very useful way to think about generalizing the pattern of what operation you want to perform on the dimension. All right. So for facts, like I said, appends. For dimensions, these are usually CRUD. Notice that a create of a data record in a table is exactly the same as append, right? You can think of it roughly to be the same. Semantically, it's the same. It's just an insert. So, how is CRUD itself implemented by software? Now, the software decides how do I deal with changes to the dimension table. Now, database supports multiple ways in which you can change, right? But the software is the one which is choosing to use a specific implementation. I mean, by that I mean the designer of the software. He or she decides to choose a specific implementation. And this has an impact on all of the downstream data science that you do, right? Believe it or not. So, when you deal with CRUD operations, right, create, read, update, deletes, you could think about persisting the changes in one of three ways. So, for a create operation, we've already spoken about it, you're just adding a new entry. So, there's very little to worry about. You're going to get a new entry, so that's easy. You know that this is a new record compared to the version of the table that was there before. So, it's easy for you to identify what's new. That's great, right? But, so rather that falls under this category of appends. So, you have a bunch of rows, that's what this white region of the table denotes, and all you're doing is just adding the new node, the new record, right? Which is a create. And that's this shaded gray row. But what if the row already exists? What if the data entry already exists? And I'm doing an update. In which case, there are two ways in which to do the updates. One way to do the update is what's called as in place, which means you pick the existing row. The existing row, let's say for instance, it's that train row, which corresponds to that Bikaner Delhi Superfast Express. And I've got the train number, I've got the train name, I've got a bunch of other fields which I'm not changing. I'm only changing the available classes because I've introduced a new rank. In which case, I go update the available classes field and do an update in place and add FC as the new class that's supported. The implication of this is that from that point onwards, I do not have access to the previous version of that particular train. Right? So that's resulted in a loss of data, a loss of information, I would say, not data per se, but information. That could or could not mean, mean important things for your business, right? It depends really on your use case. So that's what in-place updates do. The other way to deal with these updates, it's what's called as slowly changing dimensions type 2, right? So let me explain this. As the name suggests, slowly changing dimensions are dimensions that don't change often, but they change now and then. Like this example of available classes in the train. Usually when a superfast express is launched, the rates are fixed. Very rarely do rates get added or subtracted from the train. It doesn't happen daily for sure, right? It happens maybe once in 6 months, once in a year. So that's an example of a slowly changing dimension. The other example would be you as a customer of Flipkart changing your phone number. You don't do that every day, right? Unless you're a fraudster, really. But you don't do that every day. You do it maybe once in 3 months, once in 6 months. So the customer table that records your piece of information, it's also a slowly changing dimension. How do you record the update in a slowly changing dimension? There are multiple ways in which to do it. The most common way is what's called as type 2. I'll explain this now. So let's take this specific example of a product, right? This specific product table or product dimension has 3 columns: product name, ID, and description. The product name is 12-inch box, ID is 012, the description just says 12-inch blue box. Likewise, 10-inch box is another product, 010 is the product ID, 10-inch glued box, 10-inch pasted box. That's how this has been described as the product. Now, the change that we want to do is to go from 10-inch glued box as the description to 10-inch pasted box as the description. So, in effect, I want to strike off glued. I want to include a new keyword called pasted in the description field. The number of records is not changing. Remember that, right? There are still only 2 products. I'm not having a new product. I'm just updating an existing product. But in a slowly changing dimension type 2 table, I would record every single version of that table with the appropriate row ID, which is basically version ID, and the time range when that particular value was valid. So, in this case, the first table, the first product 012, that's not changing. I've just generated my own row ID, which is called as 0001, which is fine. And because that's not changing, it was started at a particular point in time. So we just pick a timestamp which is so far back in time that no meaningful real world data will come from that particular point in time. So in this case, I've just picked a date which is like in 18th century, and it's still valid, which means the validity end date has not expired. So therefore, I pick the last available timestamp which is valid in terms of syntax, which is the year 9999, December 31st. So if I take a look at this record, it says that this record was started at the beginning of time, which is basically when the systems came in for the first time, and the record is still valid. I know that because the end date, the effective end date is still is so far off, right? It's basically much farther away than the current date. The second record that exists, 0002, corresponds to the previous version of my second product, which I want to change, which I've changed basically. So in this version, the glued box description still exists. It started exactly at the same time as the first product, right, which is basically 1753, basically when the system started, but it ended on the day. So this version, the validity ended on the date that the change happened. So imagine that the change was done on May 12th, 2006, right? So that's what this notation is. So on May 12th, 2006, this version of the product 2, which is product ID 010, it ceased to exist. But at the same time, for that same effective start date of May 12, 2006, I have a new version of the same product 010, and in this new version, I have got the latest description of the product, which is pasted box. And for this version, there is no end date, which means the validity date is like the last valid date that's possible in theory. So what I've done here is I've created versions of the dimension records for every record, and this version gets created with timestamps which denote what is the effective validity period, and the row ID keeps incrementing for every change that happens. So every change is an append, right? So I've created a new row for the new change, and it pertains to the existing row by matching the primary key. In this case, the primary key is the source product ID, not the row ID number, right, but the source product ID. And the effective dates are modified for the existing row, right? So earlier this would have been December 31, 9999, but I've changed that now to the date of the update. And the newly appended row has today's date when the update happened, and validity as the last theoretical date that's possible. So the number of rows has also increased. The existing row has been changed in terms of the effective date. I have not changed the description, please note that. Only the effective date has changed. And I've added a new row which corresponds to the latest version. So in this kind of a setup, what I have access to is more information than if I just did an in-place update. That's the point about it. So we've talked about now how data inside software is stored and updated, right? Now, how is this data from the software available for analytics, available for consumers of that data? So there are three ways in which this is possible, or this is done in practice. One, the designer of the software, he or she publishes a service and allows anybody to come and pull from that service any data that they want. Typically, the service is in the form of an API endpoint, and typically the API allows you to pull specific record, like that get operation we spoke about, where you get based on a particular primary key value. That's the common approach. Occasionally, the software designers will also provide services which allow you to pull software in bulk, right? Bulk of data, batch of data. That's also possible. So this is actually the common way in which most internet-based software is designed, right? The software designers, they will work out, how do I do my CRUD operations, in-place updates, software, SCD Type-2, whatever, right? But then they say, I'm going to also publish a service, let's say an API. Allow somebody else to call that API and get the data they want. They don't have to worry about CRUD, whether I do in-place update, SCD Type-2, none of that, right? So everything is taken care of by the service. There are two types of services even here, right? One is what's called as a technical service, the other is called as a functional service. A technical service purely provides technical data which is syntactically standardized, which means all the data which is provided as output or responses from that service, all of that will have metadata matching exactly the response that you expect, and the values are standardized or consistent. But the interpretation of those values is up to you, right? So which means today I might have the available classes field name written up completely as spelled out as available classes, right? With all the AVA, AIL, AVLE, CLA, SSES, etc. Right? Now, tomorrow I might come back and change the underlying implementation because I feel that the field name is too long. I change it to avail or AC, like just the acronym AC. Now, the technical service that gets published will reflect the new metadata that's being published, right? So now it will say AC as the field that's getting returned. So the consumer of the service used to get available classes as the name of the field, but now they're getting AC. So that is a change that they'll have to put up with. But the meaning is the same. The column meaning is the same. In the world of a functional service, when the designer publishes a functional service, they provide a standard representation of the data and a standard nomenclature for the data. So you don't have to worry about changing column names internally, right? Because that's all standardized as part of a common response. So that's usually this kind of functional services provide what's called as a semantic standardization. So that's the world of software designing for people to come and pull data from it, right? For various kinds of usages. The other way around is also possible, whereby the consumer of the data, they have published APIs. So imagine you're a software provider, or rather you are IRCTC, and you have created facts based on ticket bookings, payments, and train departures. I am a partner company of yours. I'm exposing an API, right? And I'm expecting you, which is IRCTC, to call this API and push to me all the ticket bookings that have happened in you as and when they happen, right? Or maybe the end of the day. So this kind of a setup is possible when I am like a very big player, like for instance the government of India, right? I want to know from IRCTC every single ticket booking that happens on a real-time basis, as an example, right? Or the other example would be Aadhaar validations. You could be Aadhaar and all the different Aadhaar number authentications that you have logged. You want to send the data to the government on at the end of the day or real time. So that kind of a setup, the government exposes an API, and Aadhaar authority, UIDAI, pushes that piece of information, right, by invoking the API and pushing the data. So the first example was pull. So the government pulls from the Aadhaar database, or in this case, the Aadhaar database pushes, rather software pushes to the government. Now this scenario of a large system which is internet scale, which is creating very large volumes of data, calling another API and pushing data is rare, right? It doesn't happen that often, and it's mainly meant for real-time exchange of information. The third is a lot more common, which is do nothing. So the software does nothing. So neither pushes nor pulls. It's just recording all the data, facts, dimensions, etc. It's very happy about how it's doing it. It doesn't care about anybody else who wants to consume the data. This is actually, as it turns out, extremely common for legacy applications. Therefore, it is this scenario that you'll have to typically deal with when you start doing real world data science and when you start building real world big data pipelines. And to deal with this, we will take a look at in the next video some techniques of how to go about it.